Hello friends, my name is Himanshu Supani from Cobold Digital. I'm here to introduce to you a brand new project that we recently completed with NIFT Delhi. It is a research project that has been going on for the last about 1.25 years. We've been working hard at it. It has been a challenge, and I would love to introduce the components of the application to you. The research project that we're talking about is the computerized sewing skill evaluation system. This is a proprietary technology that the professors at NIFT have developed, and we have created the software application that helps in creating a national database of sewing skill in the apparel industry. So let's jump right into it. The application has been developed by our team here at Cobold Digital. Rakesh, our PHP and backend developer actually, Digambar, who's been leading our front-end development initiative, and Subham, who has been handling the Python and the more algorithm-oriented programming that happens here at Cobold Digital. There was one more colleague, Arun, whom I'd like to specially mention over here, who had played a pivotal role within this application. He has moved on to greener pastures and is doing quite well in his professional career. We wish him the best of luck. Now that this application is live, I would like to introduce the components of the application. And we're doing this in a video format because we tried to explain it in text, we tried to explain it via screenshots, but we can't showcase the enormity of the application that we've developed with just static images. So this is a brief video, 5 minutes, that explains what we've done with NIFT. So the application basically helps apparel factories evaluate the skill of their sewing operators. How it does that is by using 3 components. The first component is a web application, a web-based application, where the administrators of the CSS/ES application can control the work orders, can control the evaluators that go into the factories and perform the tests. So NIFT professors, Professor Praveer Jana and Professor Deepak Pangal, have come up with a unique methodology of testing the skill of sewing operators. The web application allows them to control the entire system. There is a desktop application that we've built. It's a cross-platform desktop application built using Electron and Node.js, which the evaluators use to go into the factories and perform the tests that have to be done to evaluate the skills. And finally, there is a computer vision module that we've built, which automatically scans, which calculates the qualitative score of the sewing operation that the operator has performed, and gives it a very accurate qualitative score of how well the sewing operator has actually performed. So there are actually 2 components to performing this sewing skill evaluation. One is a qualitative aspect that we've built, where we're using Python and Django and OpenCV to give the evaluators sewing skill a qualitative score. And then there is a quantitative score, which is calculated using this proprietary technology that is the property of NIFT and Dr. Praveer Jana and Dr. Deepak Pangal. This gets attached to the sewing machine, and it captures raw data from the sewing machine of what is happening within that machine, and gives us a way to quantitatively say that the operation was performed within the time frame, within the parameters set for that operation or not. These tests are performed on 9 different templates. 9 templates, right, Digambar? These templates are something like this, which have been designed to measure different types of operations. So there are 9 different types of templates that are used within the application, and each template is divided into grids. There is a lot of backend information that we can gather from the operation over here. Also, we collect a lot of subjective information about the operators as well. So their education, their left-handedness, whether they're left-handed or right-handed, whether they have, whether they're married or not, even that is captured within the system. So the system allows the professors to actually dissect the data in a lot of ways, and it gives a real picture of the evaluation, the skill of the operator, along with their mental and physical attributes as well. So let's talk about the technologies that we've used within this application. So the backend of the web application, the backend is built on Laravel PHP, which acts as the controller for all the information within the system. The front end is built on Vue.js and Nuxt.js. That's a front end development technology. For the desktop application, the requirement was that the entire application has to be cross-platform. So it has to work on a Windows, on an Apple system. It has to work on Linux. So we chose Electron, which is a Node.js library, to build this cross-platform desktop application. For the computer vision part, we had to choose Python, Django, OpenCV. That's the default. That has to be there. Then for the database, there are multiple different types of databases that we're using. So SQLite and MySQL are being used. SQLite is used within the desktop application to save the data locally, and MySQL is used on the server where all the information from all the different evaluators comes in. So now let's look at the demo of the application that we've built. This is the computerized sewing skill evaluation system. The first component is the web-based system, where the administrators of the application can control everything that is happening within the application. So there are multiple modules, and they control everything within this system. If you can see that there are already 62 active work orders, there are 170 tests that have been uploaded by the evaluators, which have been conducted live inside the factory. They've been uploaded by the evaluators over here. The administrators can create more evaluators as they go along, so that the application is infinitely scalable. There could be multiple new evaluators that are going across the country, visiting factories and doing the evaluations. We can have multiple organizations within the system. Organizations have units, and there are work orders which are created for every organization, which has multiple evaluators going there and performing the tests. Once the work order is created and the evaluators are assigned, the evaluator receives the work order information via email and SMS, and they have to go there and perform the tests. After this, the evaluators perform the tests on the desktop application, which we can move to next. This is the second module of the NIFT CSS system that we've created. This is the cross-platform desktop application that we've built on Electron, which the evaluators use to perform the tests on the factory floor. So they go to the factories and perform the tests live with the people, with the operators, and this is the UI that they get to see. So as you can see, that there are all the work orders that they have to work on listed over here. And once you open a work order, you see the overview of the application, overview of the work order, where you see the type of tests that have to be performed, the number of tests, the number of tests that they've created, the number of tests which are in queue, the tests which have been uploaded, cancelled. You see the entire overview over here on the screen. Moving on, let's see how the kit is connected. So this proprietary kit that I showed you, this has been developed by the professors at NIFT. This is to be connected to the system. So now my colleague Rakesh will connect this device, which captures the raw data from the sewing machine, onto the application. As you can see, the system has recognized the device, and it is now ready to record data over here. So let's now add a test within the system. To add a test, we have to uniquely identify the sewing operator. We've decided that the Aadhaar card number will be used for enrollment over here. The Aadhaar card number is saved within the system with the security specifications as mentioned by the Government of India, as has been specified by the Government of India. The Aadhaar cards, the operators can be identified nationally, and wherever they go across India, their skill would be available on a national database within this system. So Rakesh, if you can just add a sample test for Subham over here. These are the 9 templates that we were talking about. You add a template, and then we can go ahead and save and print the barcodes. Now, so from within the system generates barcodes, which you can see being printed over here. These are printed to uniquely identify the sheet and the operator within the system. The evaluator has to paste these on the sheets to begin the testing. Now, as you can see, the test is available as an active test over here. Let's put it to machine 1. Remember, this device would be connected to the sewing machine that the operator would be sitting on. Let's put it on machine 1 and let's start to record the test. Let's start the test. As soon as I press start, it's now recording the data. I'm doing this by hand, but remember, this would be the data that is coming out of the sewing machine that is being recorded over here. You can see a live chart over here. You stop that test and you're done. You can move on to the next sheet, start recording it, and it's done. So that's the process for the evaluator to perform tests at the factory floor. Once these tests are completed, they are available. The evaluator has to upload the scanned sheets over here for the qualitative analysis of the sheets. They can move to scans, where the system has all of these sheets that the evaluator has to scan and upload the images of. Once they are ready, this evaluator can simply go to upload and upload this information with their secure email address and password, and they will get, and this information then goes into the processing module, where the raw data from the machine and the qualitative information, the image, is analyzed using computer vision, OpenCV. So the administrators at NIFT can see every single sheet that has been, the test that has been performed by the operators and uploaded by the evaluator. As you can see that there is a unique barcode identifier, which is the same and automatically recognized by the system because of these labels that have been printed. You can see the created time, when was this created, when was this updated. You can see the entire data which is available in a graphical format, so that the administrators actually know that the test was performed well. You see the scanned image that has been uploaded by the evaluator. The third module that I was talking about, the computer vision module, goes through the image, breaks it down into multiple grids, and calculates the qualitative score about the stitching that has been performed by the operator on a real-time basis. All of this information is then combined to create a single score for the skill of the evaluator. This data helps the administrators at NIFT gauge the exact skill, whether it is turning, whether it's curves, whether it is straight lines, whatever it is, the administrators can gauge that information with the computer vision module that we have built for the CSS-ES system. One very important feature of this desktop application that we built is that it works completely offline. Once the evaluator has logged into the application, could be from their home, could be from their office, wherever they are. Once they have logged in, the system does not need internet to perform any operation till the time the upload is required. Why we built it this way is because the factories are in remote areas and internet is not available all the time. Even if it is available, it is very clunky. So that was one requirement that we had to work on, where all the information is stored locally and synced to the server. In conclusion, the NIFT CSS-ES project has been very fulfilling for us. Our tech team has grown. Our expertise in developing such applications has become tremendously good, where exploring all of these new technologies, the different technologies which are available, building cross-platform applications, handling local databases, keeping the information secure, computer vision, OpenCV, Python, Django, Laravel, Node.js, Express. I don't know how many technologies have been built into this on top of the algorithms that had to be developed for this application. I am proud of my team here at Cobold Digital, who have exceeded expectations in building this application and continue to support the execution of this project on the ground by visiting the factories, going to the factories and helping the evaluators get in the flow of the system and understand each and every nuance that the system has to offer, the functionality that we've built. I am thankful to my professors at NIFT Delhi and the team who has worked to build this application here at Cobold Digital. Thank you, and I hope you've enjoyed our small little overview of what we're doing here at Cobold. Thank you.